Hello, in today's class I'm going to teach us latitude and longitude in mathematics, and these are my objectives. So let's go straight to what I have for you today. I want to solve some solutions of um, latitude and longitude questions from WAEC past question. I'm starting with this one, 1993 number 12 WAEC question. It's a theory question. I want us to pay attention and follow this lesson very well. The question says 2 points P and Q in latitude 55° north. So you know what this means now. I mean, these 2 points P and Q, they are standing on this latitude 55° north, and their longitude are that the first point P, the longitude is 33 degrees to the west. The second point Q, the longitude is 20 degrees to east. You can see respectively. Okay, let's see what they want us to do now. So calculate the distance between P and Q measured along. See, the first one says parallel of latitude. The second one is a great circle. So for us to solve this question, we need to have the sketch. It is from the sketch we will know what we are going to do. But this question is a good one because this second part, they ask us to calculate distance along great circle. It's a kind of confusing part of the question. This second part of the question, sometimes in some exam questions, they will tell you to find the shortest route between 2 points. So another way to tell you to find the distance along great circle in this question is it asks you to calculate the shortest route. So I will explain everything in this example as we move on. So let's see this demonstration first before we go straight to the solution. So this is our sphere that represents the Earth. You can see the North Pole and you see the South Pole. Then this is our two reference line, the prime meridian. You can see it from north to south. This is the reference longitude and it's 0 degrees. Then you see the latitude, the horizontal line that goes around the Earth. This is the horizontal circle. That is the equator. It's called the equator, which is the reference latitude. Now let's start with what the question wants. It says the question says P and Q are 2 points in latitude 55° north. So let's locate this 55° north. I want you to see this picture very well. That's why I'm using something like this. I don't want to go straight to the solution because some people may not understand it very well. Let's get a point on this place. Okay, let's just call it point A, but I don't even need the name. Let me remove the name. Don't want it. Okay, let's get our latitude on it. Okay, so this is our latitude. Okay, so let's get the angles that we may be asked to find. Okay, let's see now, which is so we have from this point to this point, this point to this point. Okay, then let me remove this. Okay, let's put our angles. Okay, all right, so this is what I want you to see. So you can see it now. So this point will give us our latitude. You can see as it's rising up, the latitude is going towards north. This is towards north. You can see it till you get to the North Pole to give you 90 degrees. You can see the angle. Then as you return back, you can see it till you get to the latitude. You get your 0 degree latitude. Then you can do the same towards south. You can see the angle is increasing till you get to 90 degrees south. You can see that is 90 degrees. Then you can see it well. 90 degrees south. Then you can return back just like that. Okay, so this question says 55 degree north, so let's leave it at 55 degree north, 55 towards north. Okay, so this is 55 degree north. You can spin it to view it very well. So you can see the circle, you can see there's a small circle. So that's why we call it lines parallel of latitude or small circle. Okay, now let's introduce the other 2 points that they asked for. They said longitude 1 is 33 degree west, the other one is 20 degree east. Okay, let's get our point. So this is west, this is east, then one is, okay, they are P and Q. Okay, let me label them P and Q. So the one towards west is called point P, then the one towards east is called point Q. Okay, so you can see it, this is our 2 points P and Q. So let's introduce our longitude, lines of longitude, so that we can see it clearly. So this is our line of longitude. Okay. Let's get our angle. All right. Okay. So need just the value. And need just the value. Okay. So I think we can see it well now. So the question says 33 degree west is point P. So point P is 33 degree west. So you can see it when it's at 0 degrees. This is the angle for west. You start moving west, it says 33 degrees. Okay, so this is 33. Then the other point is what? Let's see. Point Q is 20 degree east. So 20 degree east. So you can see east towards your right. So 20 degrees, let's keep it at 20. Okay, so this is 20 degree east. If you view it from the top, you can view it very well. Towards east, you see 33 degrees. Sorry, towards west, 33 degrees. You can see it. Then towards east, 20 degrees. So these are the 2 points, P and Q. You can see it. Then the major target now is we should find the distance along the latitude. This one is simple. You can see that this is the lines of latitude. So the distance PQ, you can easily get it. It's very easy. All you need to do in that case is to get the angle between P and Q. So angle between P and Q, you can see it, 33 plus 20. This is the angle between P and Q. Very simple and it's okay. So let's do that one first. We'll explain the other one later. I mean, to solve this, all you just need to do, don't forget, if you want to represent your work on paper, you don't have a solid shape on your paper. Your paper is a 2-dimensional shape. So all you need to do is on your paper, you get your compass and your pencil, you draw your circle, get your circle, then the next thing is you get your ruler so that you get your equator, get your equator line. Okay. So this is what you do when you want to submit your work on paper. Okay, let me erase this a little, it's too much. Okay, then you label your north and your south pole. Then you label your west and your east. Okay, then the question says 55, so you rise up north, you draw your mark. Make sure you label it. This is 55 degrees. 55 degree north. 5 degree north. Then 33 degree west. We go towards west like this. This is what you do when you want to submit on paper. Make sure you label, very, very important. 33 degrees west. And the other one is 20 degree east. So towards east, you draw a line like this. Also label it, it's very important. 20 degrees east. 20 degree east. So now that you have this, you label your point. This is point P. Then you have your point Q. So that is it. Then if you wish to show the angle where they meet, the angle will be somewhere here. This is the angle. So this is the angle between P and Q. So with this on your paper, it shows that you understand the question. So this is what you draw as a solution diagram before you go to your solution page and solve. So to solve the first part A is very easy. Along parallel of latitude, you saw when I demonstrated it the other time. Just get the distance from P to Q along this parallel of latitude. So what you do in this case first is you get the angle, which is number 1 now. Number 1, you get the angle. So angle, let's get our angle. So angle between P and Q is, let's put it there. So the angle is, which is 33 plus 20. Then it's going to give us what? It's going to give us 53. So 53 degrees. So this is the angle between P and Q. Angle between P and Q. You saw it from the illustration in the other diagram. Okay, let's go straight now. Now we need to get the radius of this place. Let me show you. We need to get the radius. You can see that this is a small circle. We need to get the radius. That radius from P to the center here, or radius from Q. If you watch it like this, or radius from Q to the center. You can see that it's smaller than the bigger radius from the center to the equator. These are great circle or longitude. This is smaller. So how do we get this radius? We use our small r is equals to capital R cos alpha. So capital R cos alpha, you can see it. So the alpha is the latitude. In our previous class, I think you saw that place. The alpha is the latitude. So let's move now. So R is going to be equals to, we have our radius, the radius of the earth as 6,400 times cos 55. By calculating 6,400 times cos 55. Let's use our calculator to check that. 6,400 times cos 55. Okay, so it will give us 3,670.889. 3,670.889 kilometer. Okay, so this is the radius. Okay, now that the radius is known, so what do we do to continue now? We get the distance between PQ along parallel of latitude. Take note. So that is why we need the small letter r. But on great circle, you will use capital letter R. Okay, let's start. Let's take D as our distance between parallel of latitude, since it's a small distance, which is theta over 360. Theta over 360 times 2 pi r. So this is the formula we use in this topic to calculate distance. This is the major formula. The radius is the only difference. Just know the point on which the 2 points are standing. If they are standing on latitude, you use small r. If they are standing on great circle, you use capital R. That is all. They know the angle between the 2 points. Okay, let's substitute and get our value for D. So D is equals to the angle between the 2 points now is 53 divided by 360 times 2 times pi is giving us 22 over 7, and times R is giving us, okay, we have calculated the 3,670.889. So that is it. So from here we can get our distance. D is equals to, you can use your calculator and check it. Let me do that one here very fast. So 53 divided by, okay, so 53, 3 divided by 360 times 2 times 22 over 7 times 370.889. So it's giving us that. Let me put it in decimal. Okay, so the answer is 3,397.029 kilometer. Okay, so that is the answer along parallel of latitude. So you have found this one now. Okay, now let's move to the other part. Let's see. The other part says let's find the angle, let's find the distance between P and Q measured along the great circle. So this is what I was telling you about. They can ask you to find the shortest route between 2 points. You can see these 2 points now. Okay, you can see them, point P and point Q. The one we just calculated is this distance P to Q. Sometimes they can ask you to find the distance along great circle. So let me show you how it will look like here. When we say distance along great circle, you can see what you can see in this place is along the small circle parallel of latitude. You can view it here, P to Q. You can see it. So if you want to see the one along great circle, let me put it here. Let's see. It's something like this they want you to see. Have this, have this, and you have this. So this is what they are telling us to do. So this is what they want you to do. You can see it clearly. You can see it. Let me remove some lines so that we can view it very well. Let me see which line I need to remove now. Okay, you can still see it. I don't need to remove any line. Let me just zoom it. Let me just zoom it so that you see it very well. Okay, so you can see this arc. This one, this is the line along the great circle. This one, you can, if you look at it very well, you see that it's shorter than the PQ line. The PQ line. So this is what they want you to calculate, this distance. And remember, in this topic, what we do is we need to know the angle. Is the angle that's our major target. So how do we get this angle from P to Q? This is the angle. If you can get the angle between PQ, then you can get it. So let me hide this one. Okay, so this is what we are talking about. You see it now along the great circle. So this is the angle between P and Q along great circle, but we don't know it. So we need to calculate it. We need to calculate this angle. You can see it, this angle. So how do you calculate it? You need to use your knowledge of length of an arc to calculate it. Because if you study this shape very well, you see that this is 33, this is 20. The angle between P and Q is 33 plus 20, which is 53. I think you can see it clearly when you view it from the top. 33 plus 20 to give us 53. This 20 plus 33. But this other one now, we don't know the angle P and Q. We need to calculate it. So if I want to do it, if I join the line like this, let's say I join P to Q, you can see that a chord has been formed. See, a chord has been formed. Let me extend this very well so that it will be bright so that you can see it very well. I want you to understand this thing very well. See what we are talking about. If you look at it on this way, you will see that P and Q, you see, this is the angle between them. The one that gave 53, we have calculated it. Then now P and Q along this parallel of latitude, you see this one on top. You can see it. So we need the angle between them. The latitude is 55. See the one it's using moving up, which is this one. This angle here. You can see it is 55. I think you can get the diagram very well. Okay, now I've joined this place now. You see this straight line I joined from P to Q. You can see this straight line. So this is a chord. So we have a chord common to the two shapes. If you want to put this on paper, you can see what we have here. If you want to put it well so that you understand it very well, that means you see the first one we did, P and Q. That means from here you are coming down like this. See, you are coming down like this. See, then here you are going up like this. You see what you have. So the shape that is formed here is something like this. So this is the shape that is being formed. You have a shape like this, something like this, something like this. Let me remove our ruler from there. Have something like this. They have something like this. So this is part of the solution. You need to draw it as you are solving it. Let me erase this. Okay. I have my pencil. Then this is the chord I'm talking about. When you draw this one straight, so this is a chord. Then this is the P, this point P. This is point P, then this is point Q. This is point Q. Let me put it well. Okay, this point Q. Then this angle has been calculated. This is this angle, 33 plus 20. So this angle gives us 53. We have calculated this one. So this is the angle we need to calculate now. So if we can get this angle, let me still call it theta. So if we can get this angle theta, then it will be easier for us to get the distance between P and Q along the great circle. I think you get it very well. Just wanted to understand the shape very well. So this is the shape that is being formed. I know they are all in a circle. So this line is a chord. This line is a chord. So we need to get the length of chord PQ. To get the length of chord PQ, it will be equal to both sides. That is all we are doing. So the length of chord PQ will be equal to the length of chord PQ there. Then take note, This is a small r. This length is small radius. This length is small radius. Then this length is capital radius. And then this length is capital radius. While this length is capital radius. So this is radius. So take note of that. So this PQ is a chord. So we can now get the length of this curve. We get the length of this curve, we'll equate it on both sides so that we can get theta. Then from there we can calculate the distance along great circle, which is this what I'm trying to show. It is this line. No, this is the big R, capital R, and then this is the chord I just did. This is the chord. Then when you look at it on top, when you view it on top, you look at it on top, you see the angles now. The 33 plus 20, that it is between P and Q. We have done this one already. We have calculated this distance already. So we need this one that will come up like this. This is the one we need to calculate along the great circle. If you understand this analysis, this work will be easy for you. Okay, now let's go straight and see how we can do it. So what we need to do here now is, okay, now let's go to the second part of the question that says we should find the distance along great circle. So which is the B part now. So for you to get the B part question, you need to get length of a chord. So we need the length. You need to get the length of a chord. I hope you still remember the length of a chord formula. So length of a chord is 2r, that is 2 radius. 2 radius sine theta all over 2. So this is formula for length of a chord. So the radius is the radius of that, for the radius from the center of the circle to the circumference, this radius. Let me just show you what I mean by this place. So since this is a curve, you can see PQ, this is a curve. Then this is the line that moves to the center. That's what I'm trying to do in this place. You know, this is the center of the circle. There's a circle round. So this chord is common to both of them. Let me show you with this solid shape here. This is what I'm talking about. You can see it now. You see this chord. This is the chord. So this is the chord. So this chord is common to this arc. If you look at the parallel of latitude, you see the parallel of latitude PQ. You see the chord. This short dashed line. This is the chord. If you look at this other one along the great circle now, you see the great circle line. You can see it to the bigger one. This distance along great circle. You can see it. So it also have the chord. This chord is also common to it. So since the chord is common to it, we'll use, that's why we want to use that formula, this formula, to calculate the length of the chord, to equate both of them, and we'll get our theta. That is all. When you get the theta, you can now use the normal theta over 360 over 2 pi r to calculate the distance along great circle. So how do we do this now? So we start now. So we remember we use small r for parallel of latitude, then capital R for great circle. So all I will need to do in this place is I'll use my 2r sine theta over 2. This is for the small circle parallel of latitude. This is going to be equals to 2r sine, you have your sine theta all over 2, but the r we are going to use in this place is capital R. So this is length of chord for the great circle, length of chord for the small circle. They are equal since both of them share the same length of chord. So by the time you get this, your equation is okay. You know your small r. We have calculated this. Look at it, 3,670. Then capital R is known, which is 6,400. Then theta for the small r, we calculated it the other time. Angle between P, which is 53. We know this, so I'll put 53 here. So this is 53. Then theta for cap, this is what we need now. This is the angle we are looking for. If we can get this angle, then our work is over, which is this. This is the angle we are looking for. If you get the angle between P and Q along parallel of latitude, you can see parallel of latitude. If you can get this angle, this is the angle we are looking for. If you can get this angle, then your work is over. So that the angle between P and Q along the big circle, you can now use it to do your calculation. So that's what we are talking about, which is the same thing as this big angle here. You can see it from here to here. If I can get this angle, then my work is over. We'll finish our solution. Okay, now let's move on with the calculation now. So our next step is, so let's simplify this with our calculator. Let's use our calculator to do that. We have sine 53 divided by 2 is going to be equals to 0.446. Let's take 4 decimals. 0.4462. 0.4462. That is 2 times radius is 3670.889, then times 0.4462. Let me check it again from our calculator. 0.4462. Alright, 0.4462. Then this will be equal to 2 times 6400, then times, we don't know this angle, so this is the angle we are looking for now, which is sine theta all over 2. Alright, okay, let me shift to this side. Let me shift to this side. Okay, I need to position my work very well. Okay, let's shift it. Okay, alright. Okay, I think we can see it clearly now. Now let's simplify this. I will not waste time on this. Let me do it in this my screen here. 2 times 3670 times 3670.889 times 0.4462. It's giving us this. Let's put it in decimal. I mean, this left hand side is 3257.901. Let me check. Hope I didn't make mistake. 2 times 367.89 times 0.44 is correct. So that is the answer for the left hand side. Then this one will be equals to, so 2 times 6400. This one will not be difficult for us. 2 times 6 is 12,800 sine theta all over 2. Okay, then the next thing is to divide both sides by 12,800. And divide both sides by 12,008. Let me rise up a little. Okay, you divide both sides by 12,008. You are going to have sine theta all over 2 is going to be equals to 3275.901 divided by 12,800. Alright, then sine theta over 2 is equal to, let's simplify this and see the result, 3275.901 divided by 12,800. Okay, so giving us 0.256. 0.256. Okay. Okay, let me leave this answer. Okay, it's okay. 3 decimal is okay. Or let me just leave it in. Let me leave the answer to 4 decimal places. Let's leave it to 4 decimal. Okay, that is 2559. 2559. Okay, let's leave it to 4 decimal places. Okay, so the work is progressing. Now we need to find the sine inverse. Let's move down. Let's find the sine inverse of 0.2559 so that we can move ahead. Then we now have theta over 2 is equals to, you find the sine inverse, which is sine raised to the power minus 1. So the sine inverse of 0.2559. So this is the sine inverse. Then now when you get that, you have your theta over 2 will be equals to, let's use our calculator to do this one. So the sine inverse of 0. Which is this, sine inverse of 0.2559. Let me check. Hope I know miss it. 2559 correct. 0.2559. The result is 14.8269. 14.8269. 14.8269. Then the next thing is theta. Theta will be equals to, you cross multiply 2 times 14.8269. Okay, then finally let's move down a little. Okay, finally theta will give us what? Finally theta will be equals to, when you multiply this, let's just do it here, 2 times 14.8269 is giving us 29.654. So this is the theta we need. With this theta, the distance will now be easy for us to calculate. So with this, we can do our distance calculation here. We are not going to have any problem. So how do we do that? You see, the distance formula remains the same. Now that angle is known, the distance is along great circle. Don't forget, the distance is along great circle. You can see it, distance along great circle, which is 6400 is the radius we are going to use. So let's do it here and finish our solution. Let's still move on. Let's do it here, which is capital D will now be equals to theta. We have calculated it, which is 29.654 divided by 360 times 2 times 22 over 7, that is the pi that is given, times radius, which is 6400 degrees. Okay, yes. So with that now, therefore our capital D, let me shift this from that direction. Therefore our capital D, which is the distance the question asks for, will now be equals to, let's just simplify this once and get our answer. Use your calculator and get your answer directly. 29.654 divided 360 times 2 times 22 over 7 times 6400. I put it in decimal. So that is our final answer. 3,013. Sorry, 3,000. 313.717 kilometer. So this is the answer along distance along great circle. You can see all the steps. It's not a difficult one. It's a very simple question, but you need to understand the question very well. So take note of this example. See, everything is clear. Everything is neat. Just follow the step. Why this question is long is because of this angle. You must know the correct angle to use in this topic. That's why I started in our first topic that angle between 2 points, you need to know how to do it. That's why I treat it as a topic on its own for you to understand it very well. So you can see what results in this, because the line along great circle, which is P and Q, you can see how it rises up. So this is the line along great circle. You can see the great circle round. So it created another angle. You see it. So this angle, we need to calculate it by using length of a chord. Then the distance from PQ, you can see it here, PQ. You can see they all share the same chord. That is why both chord needs to be equal. Small radius chord equal to capital radius chord. And that is all with this question. Final answer 3,313 for great circle, then 3,397 for small circle. You can see that the great circle length is smaller than the one of small circle. This is 3,397, while this is 3,313 is smaller. That's why we call it the shortest route. So when they ask you to find distance along shortest route, always use great circle to calculate it.